Hello, everybody. My name is António Correia. I'm a professor in the Polytechnic Institute of Coimbra, School of Engineering, and I will present to you a study which has been carried out in the scope of our student Nuno Coelho master thesis. This work is about the fire safety in hospital buildings with performance-based analysis. I'd like to thank my other co-authors, Professor Susana Menezes from the Polytechnic Institute of Coimbra, and Professor Nuno Correia from the Architecture Department of the University of Coimbra. So first, the introduction or motivation for this work. The risk of fire in a hospital building is a topic of extreme importance for the safety of the population in general. The publication of fire safety regulations aim to improve the conditions for preparing the buildings, not only the new buildings, but existing buildings in the event of a fire. So we are going to use a case study of an existing building, and we are going to propose movement in the evacuation. Particularly hospital buildings, special care must be taken to safeguard them, mainly to the difficulty in evacuating bedridden people and people with limited mobility. The current regulation prescribes the performance of fire drills. So we all know that this is not easy because it's not possible to carry out fire drills with real patients. So we need as much as possible to carry out numerical simulations to study and to improve the emergency plans. So the objectives: first, validate the regulatory requirements on fire safety measures to apply on medical buildings. This validation is important because we need to know, in this case, the building complies with the regulations, and we want to know if the compliance with the regulation is enough to provide safety to the occupants, analyze the emergency plan of the building, and eventually improve this emergency plan. Carry out performance-based analysis, because we believe that in the future, the special buildings require an analysis of this type, a performance-based analysis, and an hospital is a special building. Test the possibility of increasing the efficiency of the smoke system. We are going to propose new solutions for the smoke control system of the building. Also very important to limit the carbon monoxide concentrations to values in such a way to prevent human harm during the evacuation. So our case study is a private clinic in Coimbra. Hospital da Luz is probably the biggest private clinic in Coimbra. In the left picture, we have a lateral facade of this hospital. And in the right side, we have a picture of the 3D model of this building in Revit. And of course, we have used PyroSim software, PyroSim and Pathfinder. PyroSim to simulate the evolution of the fire, the propagation of the flames, propagation of the smoke, and Pathfinder to simulate the evacuation of the building, considering the occupants. So you are all aware of the potential of this software, and of course the use of this software in academic environment is a courtesy of Thunderhead Engineering, and I would like to thank Thunderhead for giving us this opportunity. Not only the accuracy of the modeling of the building in terms of defining the windows, the doors, the materials. We are putting special attention in the materials of the floors and ceilings and walls. But in this case, it's very important to program our model, the definition of evacuation times, we are not using stretchers. We are considering that our patients are going to be evacuated in their beds, but we have considered the values of this study from FEMTC in preparation time, horizontal speed, and stair descent speed, depending on if we have female or male people, if we have two persons or four persons. We have here very important information for our simulation. Also very important, the effects of fire in humans, particularly the concentration of carbon monoxide and its effects on human beings. So we can see by this table, this left table, that above 0.2% of concentration, carbon monoxide concentration, we have headaches after 10 minutes, collapse after 20 minutes, but for higher values of carbon monoxide, this is very, very dangerous for people. So I will now present our fire scenarios. We have considered two fire scenarios in two locations, one in the internment ward and another in the external consultation areas. For each of these scenarios, two situations, one with the existing smoke system and another with a proposal. So this picture shows the fire scenario A, which was considered on the second floor in the internment ward, in the living room in the middle of the hallway. And here I'm showing you these two tables, the clinic existing smoke control system and our proposal. You can see that we are proposing the same number of extraction and insufflation fans, but we are proposing an improvement, an increasing of the flow, the flow in cubic meters per second. So we are proposing an increase of from 3 to 6 cubic meters per second in the extraction flow, and an increase from 3.4 to 7 cubic meters per second in the total insufflation flow. Scenario B is in the outpatient consultations. In this case, it's at the reception in second floor. Again, these two tables intend to show the existing smoke control system and the proposed smoke control system. We are maintaining, in this case, the existing system, and we are proposing another extraction fan with a flow of 4 cubic meters per second and another insufflation flow. So this way we can increase both extraction and insufflation flows from 12 to 16 cubic meters per second. Now, some results for scenario A, we have 26 bedridden occupants, 10 medical staff, which are going to help in the evacuation, and we considered that it was needed 10 additional staff, maybe firefighters or staff from other services arriving 8 minutes after the alarm. In these graphs, we can see that the evolution of the number of occupants in the rooms with the building smoke control system, we need 1,444 seconds. And with our proposal, improved smoke control system, we can reduce this time. We need 1,160 seconds. So we have here a reduction of more or less 300 seconds, which means 5 minutes. I have here a small description of this scenario A with the proposed smoke extraction system. At 60 seconds, the evacuation alarm is given. The smoke extraction system starts, opens the skylight in the waiting room. The evacuation of bedridden users begins. At 230 seconds, the first bedridden occupants arrive at the concentration zone. We have, in both cases, concentration zones to help the mobility of the beds. At 480 seconds, the firefighters arrive at the beginning and begin the evacuation operation. In part of the corridor, visibility is above 18 meters, which is very good. The maximum value of concentration of carbon monoxide in the ceiling is 0.6%, which is a very good value. At 550 seconds, firefighters begin removing bedridden occupants. At 1,160 seconds, the last bedridden occupant is removed from the second floor. So we can see here the difference with the other simulation using the buildings system, which is the time. This time is much bigger. For scenario B, we have considered 217 occupants. 16 of them are in beds, and again we have considered 10 additional staff, maybe firefighters or other staff. So I have here some description. Between 20 seconds and 30 seconds, the health technician will check out what is happening and returns to the room. At 60 seconds, the occupants were checked to exit via the emergency stairs. The evacuation alarm is given. At 132 seconds, the evacuation of bedridden occupants begins. Visibility in the main corridor is restored, but in the other corridor, visibility is practically null, because this situation, this description is with the existing smoke system. At 456 seconds, the last bedridden user is removed. The concentration of carbon monoxide reaches values between 1% and 2%. So this is much higher than 0.2%, which already causes symptoms, important symptoms in human beings. In 480 seconds, the fire crew arrives. The last bedridden user evacuated from the floor enters the concentration area. In the secondary corridor, the concentration of carbon monoxide continues to increase. So we can see here that in this case, the difference in time for the evacuation is not so important. 383 seconds with the building smoke control system and 330 seconds with our proposal. So we can see that in this case, this proposal is not so interesting. Here are some pictures. We can see here the concentration of carbon monoxide volume fraction, and the reception temperature, which is about 500 degrees. Another important topic that we have analyzed is the eventual traffic jam in the concentration zones. So we need to know if the number of beds is big for the place that we have allocated to concentrate and help for the evacuation. So to finish, the results in this table show that for scenario A, there is in fact a reduction, more or less 5 minutes in the total time required for evacuation. And in scenario B, the total time is not affected by our improvement in the smoke system. So the conclusions in scenarios A and B, we have carried out alternative situations considering improved smoke controlling systems. It was observed that only in scenario A we could observe a reduction in the evacuation times. It was concluded that depending on the part of the building, because scenario A is in the inpatient ward, so people are in beds. So in this case, it's beneficial to improve the smoke control system, and not so much in scenario B, in which we have mainly people with no limitation. So in this case, it's not necessary. It's not advantage to put that improvement in the system. Another important conclusion of this work was that the firefighters may be of important help in this evacuation, because we don't know if the nurses or medical staff are adequate to carry a bed down the stairs. So we think that maybe the firefighters could help in this procedure. So here I have some pictures of our simulations, temperature evolution, also the oxygen concentration. We have looked for this topic, and the evacuation of the patient. Just to finish, I'd like to thank again the Thunderhead Engineering for free assignment to our students, academic licenses of PyroSim and Pathfinder. And I thank you all for your attention. Thank you very much.
Yeah, okay. Welcome. Thank you for the talk. Let's see, do we have any questions in the room? Yes, here. And see if you can hear them through the speakers. If not, I can repeat.
Hi, thank you for your presentation. I would like to understand what was the heat release rate that was used in this simulation, and did you consider the interaction between the sprinkler activation and the smoke at the ceiling?
Let me see if I could understand. The question is about the sprinkler system. If there is
yeah, there were two questions. The first is, what was the heat release rate of the fire? And then the second question was the consideration of the interaction of the sprinklers and the smoke layer.
In terms of sprinklers, there are no sprinklers in this inpatient ward. Okay. The Portuguese regulations do not require for this building. I must say that this is, of course, a special building because we have people with reduced mobility, but it's not so big building. We have the district hospital in Coimbra, which is 15 stories, okay? Very high building, not this one. This one is more recent building. It complies with the regulations, but it doesn't have sprinklers, so that's why we didn't consider it. About the heat release rate, I must say that I cannot answer that question because my student should be the one who know that. I can tell you that we have tried to simulate as much as possible real fire scenario. Okay, we have considered the beds, the curtains, all the materials that we have in an hospital, and for sure, comparing with other buildings that we have modeled, I must take this opportunity also to thank Thunderhead Engineering, because this is the first time I am not in person, but I am live with Thunderhead people. For several years now, we have had the opportunity to put our students to work with this software. And of course, it's a very powerful software. And in my opinion, buildings like these, like industrial buildings or all the urban areas buildings, we can only assess the fire safety using this type of studies. So I thank again Thunderhead Engineering for this opportunity. But in terms of the fire load and the heat release rate, I cannot tell you the real value, but it's not a big value.
Would it be in the paper?
I don't think so. Not in this paper, but it would be in the master thesis of Nuno Coelho, and I think you can find it in Academia or LinkedIn. I'm sure you can do it.
Okay, thank you. There were two other questions here. One, how did you determine the travel speed of the firefighter?
The travel speed of firefighter were considered equal to the ones of the medical staff.
Okay.
Okay, and we didn't consider any other different speed.
Yeah, there was another kind of related question, but how was the fire brigade intervention time calculated? The comment here is that it is a bit optimistic for them to start assisting within 550 seconds.
8 minutes, we think that the distance between the firefighter department and this clinic is very short. And we understood that when there is a fire alarm, for sure, 2 vehicles will go to the clinic. And it's also written in the emergency plan. So we think that this time is not very optimistic. It's realistic.
Okay, okay. That's all I have. Any other questions in the room? No? One here in front. Last question.
Did you have a chance to make an exercise for the firefighters to carry down the beds along the stairs? Because I think it makes a large difference to the stretchers that Eve Hunt presented. And I would like to know, because the bed is heavier, a lot heavier, and not as maneuverable than the stretchers. So are there experimental data to this?
Did you understand the question?
I couldn't hear everything.
Okay.
Can you please help
Yeah,
me?
sure. So did you consider the time or the velocity of carrying beds down the stairs? Because Aoife Hunt presented some study in a previous conference about the time it takes to maneuver these larger patient carrying devices down the stairwell. So how was that factored in to the study?
We have considered that these beds have wheels, and they have the possibility of being transported like a stretcher. Okay, they are very light. They are not very big. They are chosen to be used with the space they have, and we have considered the same times. And we think it's appropriate. It's more or less it's correct to use these times.
I think maybe the question also is, were you using the vehicles, like a bed-sized vehicle in the stairway, or just cylinders representing the patient?
No, the bed size. The bed size.
So taking up a little more space and
yes,
use some speed for that.
Detail is in the master thesis. It's not in the paper, but in the master thesis of Nuno.
Okay, good. Well, thank you very much for joining us for the Q&A. And
I thank you very much.
We will move to the next speaker. Thank you.